Hi everyone, and welcome to your very first video in CSForEveryone.com. This is a website that's intended to teach people who have no experience with programming or computer science the basics and more advanced concepts within computer science and programming. So, what is computer science? Like, why are you here? What are you trying to do? Well, I'm assuming a lot of you just want to learn how to code, and that is what we're going to do. But we're also going to learn important theoretical computer science subjects. Computer science itself is not purely coding. It's more broad than that. Computer science is the study of data and algorithms that we can use on that data. So, what exactly is data? Well, it's pictures on Facebook, it's all those folders on your computer, it's all those video games that you play, it's all of those videos on the YouTubes, it's all that. That is all data. And the number of algorithms that go into making all of those work is pretty crazy. A big question that computer scientists ask is, how can data be organized into structures that can still function efficiently at great scale? And this is critical because you need your data to be accessible no matter how big the data set gets. For a website like Facebook, where there's millions of people, and each of these people have hundreds of pictures on their Facebooks, you don't want Facebook to be slow. You want it to be fast. And so they have to organize their data into proper data structures and use proper algorithms on these data structures to accomplish these goals. So what are algorithms? It's a very simple definition, actually. An algorithm is a series of self-contained, easy-to-follow steps that together form a process. Hopefully this process is usually a solution to some sort of problem that you're hoping to solve. An example of an algorithm: baking a cake. So step 1 would be preheat the oven. Step 2, put the cake in the oven. Step 3, wait 20 minutes or 25, whatever you set the temperature to. Step 4, remove the cake from the oven. Hopefully you used an oven mitt, else you'd burn your hand. 5, eat the cake. So algorithms are everywhere. That's just an example of one. And you knew how to do that, but you didn't know that that was an algorithm. And now you know. In computer science, I will say, most algorithms are expressed in computer code. So what exactly is computer code? Well, computers are built to only understand one language, and that's called binary. Binary is a series of ones and zeros that, when they're all paired together, can be used to represent almost any concept. All those video games and YouTubes that you play and you watch, at some level, at the lowest level, that is literally just ones and zeros all coming together to be represented as some sort of thing. That's all anything in a computer is at the end of the day. In your computer are electrical components called transistors. In very basic terms, this is not completely correct, but it's enough for you to know. Transistors can store or release electricity. They are amplifiers. They can increase the amount of electricity to a certain point. So in a computer, near a transistor, if there is an electrical charge at this point, then that is considered to be a 1. And if there is no electrical charge, then that is a 0. So let's go ahead and go to MS Paint here, draw a few bits. These are bits lined up on a circuit board or on a computer chip. So let's put electricity going through some of these. This one has electricity going through it. This one has electricity going through it. So these do not have electricity, these two right here. So this would be 1, 0, 1, 0. That's all it is. It's a 4-bit string, because there's 4 bits. 1, 2, 3, 4. It's a 4-bit string that is 1, 0, 1, 0. So electricity is here, is not here, is not here. That's all it is. At the physical level, it's just electricity being there or not. So you don't want to have to worry about that, though. You just want to code. You don't want to work with pure binary. And because of that, people of the past and of the present have created and are still currently creating things called programming languages. A programming language is something that lets you type in code and it will be converted into binary for you so that the computer can understand what you want it to do. Because you don't want to write pure binary. That's, I don't hate myself. Let's just put it that way. I don't hate myself. I want to code, but I don't want to write pure binary. That's awful. So you'll be working with programming languages where all of the nitty-gritty details have been abstracted away. So a programming language lets us write code that can be converted into binary code. That's the important thing that a programming language does. So what exactly is programming? Well, programming itself is the process of coming up with an idea and turning it into an executable computer program through code. Computer science is a very broad field, and programming itself is not the entirety of computer science. Computer science itself is extremely broad and asks many more questions than simply, can I create this program? But programming itself is a part of computer science. So in this course, we're going to primarily use the Java programming language to teach theoretical computer science subjects and to express algorithms. However, we're also going to code up projects as we go. So you'll get a good grasp on both theory and application. So while Java is going to be the main language that we use, I'm also going to give you examples of equivalent operations in other languages, just so you can understand how things work in other languages, because that's important. Because all mainstream programming languages these days have pretty much the same constructs to accomplish their goals. They all have if statements, they all have variables, they all have loops, and I know right now those three words mean nothing to you, but behind every programming language there are if statements and variables and looping and blah blah blah. So if you know the fundamentals, the concepts behind the programming languages, you can learn one language and then instantly start picking up others pretty quickly. So that covers this video. That's all we're going to talk about for now. I would recommend, once you finish watching this, go ahead and read up on the section below. It'll take you about 10 minutes max, I'm sure. And then take that quiz. It shouldn't be insanely hard. If you can answer all the questions pretty well and you understand the answers, then go ahead and move on to section 1.2, where we're going to install Java and create our very first program. Thank you.